Hello everyone, welcome back to another video course on compact redstone. This is 1-2 properties of redstone components 2, where I will introduce to you more on different properties of other redstone components that I haven't discussed in 1-1. So without further ado, let's get on to the first redstone components that we're going to discuss, which is going to be the node block. So firstly, node block is an instant updater. So here we have the setup where, as we have discussed in 1-1, piston is affected by quasi-conductivity. So we can power this piston by indirect powering, basically having a solid block diagonal to this piston, and we can power this. And a node block provides an update for this piston to power, like so. And when I say that node block is an instant updater, we can prove this by this setup right here. So here we can see a setup where this one is updated by this node block while this one is updated by this piston. And since node block is an instant updater, when I flick this lever, you can see that this piston gets powered first, not this piston, because this is related to also another concept, which is block event delay. This would be formally discussed in 2-4 tick counting and more on timings. But for in this course, obviously we are not going to discuss that too much because this is more of a complicated concept. So in introductory courses, we are not going to discuss that right now. But you can always assume that this piston will fire later than this one because a piston here is not an instant updater. So if I were to reverse this setup, you can also see the piston that is being updated by the node block will also power first. Is always this case. Yep. And another property of node block is that it turns on and off instantly and can be detected by an observer. So you can see we have this here. So both of them power at the same time. Also, at this point, I will also want to mention that you might find for more knowledgeable redstoners, you may find some of these setups may be input bugged. Well, obviously I would try to avoid them as much as possible, but sometimes you may find setups that might be affected by input bug. But on introductory courses, I'm going to ignore the effects of input bug. So this also applies to 1-1 as well. So yeah, we are only going to assume that repeater input is always the case for all inputs. So all the delay counting would be based on repeater input. So yeah, just that for you. Okay, so node block basically have the same delay as a piece of redstone dust because redstone dust turns on and off instantly, so as the node block. So they basically have no delay. So for this case, and then node block is a solid block. I would throughout this video I would use this setup where if a solid block would cut off the redstone dust here, but a transparent block wouldn't. So throughout this video, I would just use this as an example to show you if it's a solid block or a transparent block. Yep. That's all for node blocks already. We would move on to redstone lamps. So in here, we can see redstone lamp turns on instantly and turns off 2 ticks after the activation and can be detected by an observer. So we have this instance redstone wire, and then we have this redstone lamp, and we have a 2-tick repeater here. So if we flick this lever, you can see both of these pistons power at the exact same time. This is similar to this case where the redstone lamp will turn on and this dust will turn on at the same time, basically instantaneously. But then when the redstone lamp turns off, you can see that these two pistons are in sync instead, because redstone lamp turns off 2 ticks after the activation. So basically this would add 2 ticks of delay when it is turning off. So this demonstrates it. So you can see these two pistons being sync, but then turning off, these two pistons are in sync. So that demonstrates it. And in addition, redstone lamp is a solid block. We have already known this in 1-1, but I'm just going to mention it here again. So, and now we're going to go to pressure plates. This is one of the more complicated redstone components due to a certain property. But let's just discuss the basics of it. So a pressure plate exists in 4 categories: stone, wooden, lightweighted pressure plate, and heavyweighted pressure plate. I say categories because for stone pressure plate, you have stone pressure plate and polished black stone pressure plate. And then for wooden pressure plate, you obviously have all 6 kinds of woods along with 2 nether woods. So yeah. And another thing is that lightweighted pressure plate and heavyweighted pressure plate are also known as gold pressure plate and iron pressure plate because of their materials. So that can be used interchangeably. So yeah. Now the first property is that stone pressure plate can only detect mobs, players, and armor stands. So if I have a minecart here, which is on top of a stone pressure plate, you probably cannot see it with this angle. So I'm going to just use the new tools that I have. Hello. So we have this stone pressure plate here, and then we have the wooden, gold, and iron here. And you can see the stone pressure plate doesn't realize that the minecart is on top of it, so it doesn't power this redstone lamp. But then for all wooden, gold, and iron pressure plates, they all get powered by the minecart because they can detect all entities, so including minecarts. So all mobs, players, entities, they will detect, except for stone pressure plate, basically. Yeah. Here comes the complicated property that I've mentioned. So I'm going to explain it to you first. Sorry, I'm going to say the exact definition first, but then I will explain it more to you. So stone and wooden pressure plate check every 10 redstone ticks for entities on top. It will turn off if there are no entities at the checking moment. But then for lightweighted and heavyweighted pressure plate, they check every 5 redstone ticks for entities on top, and obviously they will also turn off if there are no entities at the checking moment. What I mean by these sentences is that firstly, what do they imply? For stone and wooden pressure plate, they can turn off 0.5 to 10 redstone ticks after the last entity leaves the detectable position of the pressure plate, while it would be 0.5 to 5 redstone ticks for lightweighted and heavyweighted pressure plates. And those sentences basically means that you can consider that pressure plates turn off for the activation of pressure plates, they are determined by some sort of like a clock, basically. So for like iron and gold pressure plates, they can turn off every 5, 10, 15, 20 redstone ticks. But then for stone and wood, they can turn off every 10, 20, 30 redstone ticks. So on and so on. So how do they check them? It's basically by the activation of the pressure plate. So every 5 ticks onwards, they will check if they can be turned off. And for stone and wooden pressure plate, it will be every 10 ticks after activation to see if they can be turned off. If they cannot be turned off, it will remain on. If they check that they can be turned off, they will turn off. So this is what I mean by those sentences. And yep, we can see from this here, for example, a stone button. You can see that these two turns off before these two turn on. But then for wooden button, all of them turn off at the exact same moment. Like so. This is because of the checking moment of time, where for stone pressure plate, they check that they can be deactivated faster than these, so they turn off first. But then for wooden button, all 4 of them have the same checking moments where they decided that they can turn off. So you can see that although the checking moments of the pressure plates are different, they can still turn off at the exact same time. It only depends on how long the entity has lasted on the pressure plate. So yeah, keep in mind for that. This also is suitable for a remark, which is that if you were to refer to the Minecraft wiki as of 28th of April 2022, it says that heavy or lightweighted pressure plates, they activate 5 redstone ticks after no entities are on top of it, while stone or wooden pressure plates, they activate 10 redstone ticks after no entities are on top of it. Now, from what I've said before, you can see that these two statements contradict with each other. And I would like to say that the Minecraft wiki for this description is wrong, because we have already seen for the wooden button case, if it were to be if it were to behave like what the Minecraft wiki would said, then these two pistons have to retract 5 redstone ticks earlier than these two pistons, but as we have seen already, it doesn't. They instead deactivate all at the same time, which means that the Minecraft wiki must be wrong for this description. So this is a proof to show that the description is wrong. Another proof is to have a 3-tick repeater, basically. Basically a 3-tick pulse. A 4-tick pulse also works. It behaves the same thing. So yeah, it's just to show you that all 4 pressure plates can have the same length of pulse or duration, I would say. It only determines if the entities are on top of it long enough. If they are not on top of it long enough, then then these two may depower faster than these two depowers. So yeah, that's basically for the pressure plate. You don't really have to remember this property in detail too much, because this is quite technical, to be honest. So yeah, normally it won't affect you too much, since the use of pressure plates are usually along with entities, and you would learn that only in 2-10 entity usage. So for now, you can just know this property and not really need to care much about it. But yeah, I still need to tell you about this property though, for your understanding. So yeah, anyways, so that's the complicated property of pressure plates being told. Now we'll move on to something more simpler, which is the signal strength that the pressure plate would emit. So it's more complicated for light and heavy weighted pressure plates, and it's very simple for stone and wooden. For light weighted pressure plates, it provides signal strength equal to the number of entities on top of the redstone dust until the signal strength reaches 15. So if I have a 1 armor stand here, it would provide signal strength 1 because there's 1 entity on top. So 2 would be 2. If I stand on it, it will be 3. Like so on and so on. So how many armor stands are there correspond to how much the signal strength is, basically. So yeah, once I reach 15, however, for the 16th armor stand I add, it will just remain 15 because redstone dust, quite frankly, cannot exceed 15 for normal cases. But then for heavy weighted pressure plate, it's quite different, because it provides signal strength equal to the rounded up number of entities divided by 10 on top of it to redstone dust until the signal strength reaches 15. So if I have this, if I have 1 armor stand, it will obviously activate with a signal strength 1. But if I have the 2nd armor stand, it doesn't activate the 2nd redstone dust, because I need to have 11, not 10, not 20. I need to have 11 armor stands to power the 2nd red lamp. Basically a signal strength of 2. So 3, 4, 5, 6, 7, 8, 9, 10. Still doesn't activate, but the 11th one will activate. So here I have this command block, hello, which will summon 10 armor stands basically. So 10, you can see 1 redstone dust is activated, 2 would be 2, so 20 would be 2, 30 would be 3, so on and so on. You can always play with this, and it's resetting this, just remove this block. That's basically about heavy and lightweight pressure plates. And then stone and wooden pressure plates are very simple, because when they're activated, they just provide signal strength of 15 no matter what. No matter how many entities on top. As long as there's 1 entity, it will always go through 15. That's basically it. And that's all for pressure plates. We will move on to buttons. A button exists in 2 categories, stone and wooden. For stone, there would be stone and polished rack stone. For wooden, all 6 kinds of woods along with the 2 nether woods. So I say categories. And button can be placed on all 6 surfaces of a full block. It doesn't matter if the full block is a solid block or a transparent block. As long as it's a full block, you can always place it on all 6 surfaces. So same for stone and wooden. And then here you can see that a stone button provides a 10 tick pulse, while wooden button provides a 15 tick pulse. So you can compare the differences. Like so. You can see there is certainly the wooden button pulse is certainly longer than the stone button pulse, and it's exactly 5 ticks of delay actually. So if I do this, you see this even deactivates before this deactivates. So you can see that wooden button is definitely longer. And any button, any activator button provides 15 signal strength to redstone dust. Yeah. And another thing is that the activation of a button on a solid block, redstone lamp is a solid block, will power the solid block and activate all 5 blocks adjacent to the button. So just assume that there's a redstone lamp here. It will also power. And then if I press this button, you can see that it activates all of these 5 blocks, including this one, and then powers this solid block. Thus, it will also activate all of these lamps, like so. It's also the same for the floor button and the ceiling button. They all behave the same. So yeah, that's all about buttons. We would go on to levers. The properties of these are also quite simple. Same as buttons, you can place levers on all 6 surfaces of a full block. And the only difference is basically an activator lever would provide a constant power source, and it would not turn off until you flick it again. And the same thing happens also for an activator lever, it provides 15 signal strength to redstone dust. And then the same thing here, activation of a lever on a solid block will power the solid block and all 5 blocks adjacent to each other. So this setup already shows it. It's exactly the same as a button, what a button would do. So yeah, the wall, the floor, and the ceiling levers do exactly the same thing basically. So that's all for the input devices. We would move on to containers. Now we would talk about droppers. So for this texture pack, the dropper looks like this, a bigger hole on the center, while a dispenser, which would be in here, has a smaller hole. So you can identify the differences. Firstly, a dropper transfers this would be this one. A dropper drops an item of all kinds on activation. So basically, if I have this cyan stained glass, it would just drop it as an item, as if I were to drop an item like this. And this is also the same case, for example, like a lava bucket, which you will see it behaves differently for dispensers. It will just drop it as an item. Another property is that a dropper transfers an item to another container to it when the dropper is facing on to the container direction. So if I were to activate this dropper, then you can see the cyan stained glass is in this chest, like so. Very simple. And dropper turns on and off instantly and can be detected by an observer. This is similar to the node block, as we have said before. So the dropper is like an alternative. And then this is also important. Dropper is affected by quasi-connectivity. So you can always have some very interesting circuits that can power droppers to get detected by an observer. So quite useful, although it's simple. And lastly, dropper is a solid block. You can see it through this dust. Now we go on to hoppers. Hopper has 2 kinds basically. One is downwards, one is sideways. No hoppers can go upwards, unfortunately. And a hopper picks up an item, or picks up items as an entity or as in a container from the top and transfers the item to its pointed container. So for this, if I drop an item to it, you can see it appears in the chest already. And then for this, for a sideways one, it also behaves the same thing. And if I were to have a chest on top of a hopper, it would just suck the item inside and it just put it back into another chest at the bottom. So yeah. And similar to the dropper, hopper turns on and off instantly and can be detected by the observer. And hopper is a transparent block. As you can see, this dust goes through. Hoppers cannot be powered by quasi-conductivity, which is the main difference from using a dropper. So yeah. Now we go on to dispensers. Dispensers is more complicated than droppers because for dispensers, a dispenser dispenses specific items once per activation with 2 ticks of delay. And if the item is non-specific, it just drops an item like a dropper. So this is a non-specific item. For example, it's a science stained glass. It just drops it. But then, as we have seen it before, for a lava bucket, a dropper would just drop the item as per usual. But for dispenser, it dispenses this lava instead. And this is also similar for water and powdered snow. So powdered snow is very useful because it doesn't need any blocks of support on it. I can remove this observer even. And while water and lava, you even need these 2 blocks to prevent it from flowing everywhere. So yeah, powdered snow is a very useful thing in 1.17. And I also said that it dispenses specific items per activation with 2 ticks of delay. So you can see, let me just take out the lava bucket again. If I just power it, you can see that this is 3 ticks of delay, this is 1 tick of delay. And then this block already represents 2 ticks of delay. Both of them power at the same moment. You can see that. And then another property of dispenser is that it doesn't transfer items to another container adjacent to and pointed by it. It rather drops it like an item instead. So for this one, just goes down. The science stained glass just doesn't go into the chest. Like this. So make sure to identify clearly between dispensers and droppers. Most likely you're going to use droppers instead of dispensers because dispensers are usually for specific items like water and lava, because sometimes they are going to be useful in some circuits. But then for most cases you're going to use droppers instead. And basically similar properties like dropper. Dispenser turns on and off instantly when it's and can be detected by an observer like so. And dispenser is also affected by quasi-conductivity, similar to dropper, like this. And dispenser is also a solid block. Yeah, that's it about dispensers already. We'll move on to the general topic about containers. So different containers have different number of slots, so you can see these are examples. For furnaces, blast furnace, and smokers, they have 3 slots, including this slot actually. So don't get confused. This output slot also counts as a slot. For 5 slots, we have this hopper and the brewing stand. Brewing stand before 1.9 has 4 slots only, but since after 1.9 update, it has 5 slots. And we are discussing 1.11 plus Redstone, so we always assume brewing stand have a 5 slot, basically. For droppers and dispensers, you have already seen them. They have 9 slots. Chests would be 27. This also includes barrels, which is basically like a solid block of chests, and shulker boxes, also 27 slots. And double chests, obviously 54 slots, 27 times 2 basically. So yeah, and this is another complicated property. A Redstone comparator emits signal strength according to the fullness of the container. So if I put one item in it, it just turns on. But then if I put the second item, it doesn't turn on. Only until I put the 23rd item, you can see that the second lamp turns on. There you go. No. So after the 45th item, the 46th item turns on the first slot. So on and so on. How many items are needed for a certain signal strength is calculated by mathematical formula, which I have already provided in the Word document, so you can always refer to it. So yeah. And also similarly for the iron pressure plates, how many entities are needed for different signal strength, you can also I have also included the mathematical formula in it, so you can refer to if mathematical formulas are in favor of you. But yeah, if you cannot understand mathematical formula, then just hearing my verbal explanation would be good enough. So yeah, and back to this signal strength thingy, and I said is according to the fullness of the container. So what I mean is that, for example, if I have snowballs, for one item, it has one signal strength. But then remember that when we place 23 cyan wool, it will activate the second redstone lamp. Well, for snowballs, I only need 6. Because snowballs are 16 stackable, while cyan wool is 64 stackable. So basically 6 times 4 is 24 already, because 64 divided by 16 is 4, so I can just assume snowball is a 4 multiplier. So this already represents 24 64 stackable items. So this will obviously power the second lamp. It's according to the ratio, just remember this. And if we see a full stack, would be 3 redstone lamps turned on, and then this is also similar to just having a shovel, because a shovel is a non-stackable item, so one item already represents a full stack. And it's important to know the differences between 64 stackable items, 16 stackable items, and non-stackable items, because these will be very useful for later circuits like hopper ROMs. So knowing these will be very helpful to you. So yeah. And also, let me just make another remark. If you want to know the minimum items for container signal strength, instead of using the mathematical formula, there's also a very useful table on the Minecraft wiki, which you can refer to. And I have also put it in the Word document in section 14, useful list, so you can always check there as well if you wanted to. Moving on to another property. This is more related to comparative behaviors on containers, but it's still related to containers, so I will include it here instead. A Redstone comparator only detects the most nearby container. If I put an item here, this obviously activates, but if I put an item here, this doesn't activate, even though the furnace itself is a solid block. Basically only detects this furnace. And this is also similar. When I power this redstone dust, this comparator would never turn on. For this setup, however, which is a redstone comparator detecting a container via a solid block, besides on detecting this container, it can also be powered, like this comparator can also be powered and provide a signal strength of 15 if the solid block is powered with a signal strength of 15. I should put it here instead. So what I mean by that is that when I power this block, right, so this will provide a signal strength of 15. But then if this block is receiving a signal strength of 14 or less, for example here, this cannot power. It just doesn't power. Only signal strength of 15 goes through. So that's also another important property of redstone comparators, and how its relation with containers. So back to the container bits. All containers shown here are unmovable or immovable, except the shulker box. The shulker box just breaks upon piston action. But then it would be useful to consider containers that are movable. 2 of them are cauldrons and composters. For cauldrons, it detects basically the water level, and composter detects the fullness. So for cauldron, you can always fill that up by a water bucket or by a water bottle. A water bottle fills up by 1 level, while a water bucket just fills up fully. And a bucket will remove all water, while a glass bottle would remove only one level. And you can also see that the cauldron provides a maximum signal strength of 3, and it also can be pushed. Okay, there you go. For composters, you can fill it up by using cake or pumpkin pie. These are just the examples. There are also other alternatives, but then these two are the foods that can 100% fill up a level of composter, because others are determined by probability. So you can see 1, 2, 3, 4, 5, 6, and this is a special case for 7, because a composter with a 7 level will automatically turn into an 8 level, so you can never have a static 7 level composter, basically. So this also means that there are no movable containers that can provide a stable signal strength of 7 and 9 to 10, 15. So you can only go from 1 to 6 and 8, not 7 and 9 to 15. 7 is a very special case. So yeah, that's all for containers. We will move on to the 1.6c now. The target block is a very useful block. Firstly, it can detect entities when they hit on any side of the target block. So I have this arrow that I have this dispenser that shoots an arrow to power this target block. This is very useful. You can alternatively use snowballs or eggs to hit this target block, and they will also do the same thing basically. So yeah. Another thing about target block is that it can redirect redstone dust. You have already seen this in 1-1, but then target block is useful because it's the only solid block that can redirect redstone dust. So you can also power the target block as well. So yeah, you can also see in here, target block is a solid block. So yeah, this is also the reason why target blocks are useful, because they are solid block and it's the only block that can redirect redstone. So it's very useful in many cases. And yes, that's all about target blocks already. We would move on to rails. I don't know why there is no sign here. Let me just add that back. Or I should say powered / activator rails, because we are going to discuss on these two mostly. The powering of powered rails and activator rails are not commutative. So if I power this powered rail, this activator rail doesn't power. If I power this activator rail, this powered rail doesn't power. And another thing that I have missed out in this setup is that for powered and activator rails, they can receive power from the origin to an extent of 8 blocks. So including this would be 9. But yeah, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 blocks. So you can see this rail doesn't power anymore because the signal doesn't reach far enough. So yeah, I will later add that into the world as well. But yeah, anyways, so another thing about rails is that they are instant updaters. So for here, you can see that this setup, this has a rail updating this piston, while this has another piston updating it. And you can see that this piston would have a higher priority to fire first before this piston. And it's also related to block event delay for this, again. But yeah, for now you don't really need to have a full understanding on that yet. Okay, so this property is quite special and a bit more complex, and this would be formally introduced in 2-4. Wait, no, it's not 2-4. It is 2-3. Yes, Celtic priority raising condition and its applications, I think. Let me just check that real quick. Yes, it's 2-3. Okay. So yeah, it's more related to that. topic, so it's an intermediate topic, so you don't have to fully understand it now, but it would be useful to know the coolness of rails, I guess. So if I were to power the tip of a rail, the furthest observer will always have the highest priority to power. So if I power it from here, right? So you can always see this piston will power first. So same for here. If I power from this rail, right, this observer will have the highest priority to power. So you can see this piston activates instead. Powering the middle rail here would be quite a bit specific, so not going to introduce that. And this is also similar to pushing a column of blocks actually. So if I push from here, this piston gets powered first. And if I push from here, this piston has the highest priority to power. So all of them will power, but it just determines on which has the highest priority to power. Like so. So yeah, very special property. Yeah. It's not quite useful, to be honest, but then in some rare occasions you might come across with this property being useful. And yeah, now moving on to the final two that I have for you, slime blocks and honey blocks. So slime blocks, you can see it sticks to other retractable blocks and they move in the same direction when pushed or pulled, like so. And if we account for the push limits, slime blocks and its sticking blocks also account for push limits. So you can see the piston can push or retract these 12 blocks, but then for 13 blocks it can't push nor can it pull. So if I have this right, there is 13 blocks the piston is pulling, so it cannot pull back. Yeah. So the push limit doesn't only refer to push limit, it also refers to pull limits, basically. And slime block is a solid block, as demonstrated here. So honey blocks is also quite similar to slime blocks. They have basically almost exactly the same property. They stick to other retractable blocks and they move in the same direction when pushed and pulled. Push limit also applies. 12 blocks you can see at here, and 13 blocks they cannot push. 13 blocks, this is already exceeding the limits, nor can they pull. Like so. Honey blocks, different from slime blocks, are transparent. So remember that. If you ever need transparent slime blocks, just use honey blocks, basically. Another important thing is that slime blocks and honey blocks doesn't stick to each other and move independently from each other. Like so. So with that being said, that's actually all of the properties that I have to show you. Now I would go through the exercises, and let me just make a remark. For this course's exercise 1-2, it is more challenging than usual, and I also have two challenging questions here, which is exercise 2.3 and exercise 2.8. I would go through them a bit later, but here I need to explain a basic thing first, which is you can see for some of the questions you can have this condition that we need to have a lamp that pulses. So what I mean by pulses, it turns on for a brief moment and then it turns back off. So the initial position or condition is that the lamp is originally off, then it turns on for a brief moment and then it turns back off. So that is what I meant by pulse. So this is especially important and not to be confused with invertedly pulse. Because if you were to invertedly pulse, this would be similar to this situation where this redstone torch would turn off for a brief moment and then turn back on. This is not what I want, and you can also see in this one. So, the left lamp pulses here, this condition. What I meant is I need to have this redstone lamp to be originally turned off, and it turns on for a brief moment, but then it turns back off. This is what I wanted. Not originally on and then turns off for a brief moment and turn back on. This is not the condition that I want. So just keep in mind for that. Or otherwise you may approach to these questions wrongly. So after I explained this, now I would just discuss some of the challenging questions to you. So this one is that with the resources available from the chest builder circuit such that when the lever is activated, the pistons fire to match position A, and when the lever is deactivated, the pistons fire to return to their original position. So you can see this is position A, so I want when these two pistons, so when the lever is activated, these two pistons fire such that it gives you this position, and when the lever is turned off, then you just have this position back. So you have these positions that you might want to refer to. And then for challenging questions, they all have asterisks, like here. So I have given you some reference circuits that you may want to refer to. You can always analyze on these reference circuits to see what they do. So you can always flick these levers to see what they do. And from these reference circuits, you can learn some important properties that would help you on answering these questions. So same for 2.8. 2.8 has part A and part B. So part A is to find a suitable input device such that on activation of the input device, the circuit requires to match position B, which is this one. And on another activation or deactivation, on another activation or deactivation of the input device, the circuit returns to its original position. So yeah, from this position back to this position, like so. Also, I would like to give credit to NewcomerMC and Exorden for the first construction of this circuit. There are many different varying states of this circuit, but I used this one as demonstration for this exercise. So, because this observer chain, quite frankly, can be changed a lot to other circuits, but this is the most simple one that I can find. So yeah, basically for this part A, you would need to remove the sign, or you can just place it on top of here. You can place your input device here or here, and then test if it works. If it doesn't work, then you just need to have another input device that works. So the only input devices are stone button with the button or lever, basically. And this is just part A. Part B is the challenging part. Asterisk again. Explain why the input device is suitable for the circuit to work, while other input devices are not suitable according to your own knowledge in the perspective of timings. So again, there's a reference circuit C. You might want to examine on what this circuit does and apply the knowledge from here back to here. So this is the only explanations question that I have for you. And for all challenging questions, you will also have this page, a hint, which has a question that is basically a guiding question for you to know what the reference circuit wants to tell you. You can always read them if you have troubles on completing these exercises. And don't worry if you are unable to complete the challenging questions, because quite frankly, I have not taught them in 1-1 nor 1-2, so you can always refer to later courses if you want more knowledge in them. And I think for exercise 2.3, this would be formally taught in 1-10, signal transmission methods and basic miscellaneous circuits. Yeah, there would be a certain circuits that is exactly why I want you to build it here. And for 2-8 is even more complicated. 2-8 part B, because it is related to timings, as you probably know. So this would be very related to 1-11, introduction to timings, and even 2-4, tick counting and more timings. So after learning these two courses, you should be able to answer them more accurately. And obviously, for all explanation questions, I don't expect you to have any detailed explanations of it. So for the answer of exercise 2.8 part B, I have provided two explanations versions. One would be the simpler version where where this is the expected answer that I expect from you. It's still a bit detailed, but then it is already simplified to match with a beginner redstoner's understanding. And then I also have provided a detailed explanation for you to show you what it would look like if you were to answer this in detail. So, yeah, that's basically all I have to tell you about. And yeah, as I've mentioned, the solutions are at the back, so you can always review them after doing your own exercises. And remember, if there are chests here, you're limited to using these resources. So yeah, don't worry if you are unable to answer some of these questions because all of them are a bit challenging, but accessory 2.3 and 2.8 part B. So yeah, good luck with the exercises. Please do them, as this will enhance your redstone knowledge and yeah, consolidate your redstone knowledge as well. Thank you for watching this video. The next two video courses, 1-3 and 1-4, will both be PowerPoint presentations, so there will be no Minecraft World download, basically, and also there will be no exercises. So, yep, I will only see you in Minecraft gameplay in 1-5 input methods. So, thank you for watching this video again, and I will see you in 1-3 basic terminologies. Thank you.